sklearn, linear model, RANSACRegressor. Description: RANSACRegressor implements the random sample consensus RANSAC algorithm, which is a robust method for fitting a linear model to data that contains outliers. RANSAC works by iteratively selecting a random subset of the data, the inliers, and fitting a linear model to this subset. Then, it measures the error between the fitted model and the rest of the data points. The data points with low errors are considered inliers, while those with high errors are considered outliers. This process is repeated multiple times, and the model with the highest number of inliers is chosen as the final model. Inputs: X, the training data, represented as a 2D array. Each row corresponds to a data point, and each column corresponds to a feature. Y, the target values for the training data, represented as a 1D array. Outputs: Core, the coefficients of the fitted linear model. Intercept, the intercept of the fitted linear model. Steps: Randomly selects a subset of the data, the inliers. Fits a linear model to the inliers. Calculates the error between the fitted model and the rest of the data points. Identifies the data points with low errors inliers and those with high errors outliers. Repeats steps 1 to 4 multiple times. Selects the model with the highest number of inliers as the final model. Metrics: R2 score, a measure of how well the fitted model explains the variation in the target values. Mean squared error MSE, a measure of the average squared error between the predicted values and the actual values. Visualization plots: Scatter plot of the data with the fitted regression line. Residual plot, showing the difference between the predicted values and the actual values. Fine-tune parameters: Min samples, the minimum number of data points required to fit a model. Residual threshold, the maximum error allowed for a data point to be considered an inlier. Max trials, the maximum number of iterations to perform. Random state, the seed for the random number generator. Uncertainty methods: Bootstrap, resampling the data with replacement to estimate the uncertainty in the fitted. Coefficients and predictions: Bayesian inference, using a probabilistic model to estimate the uncertainty in the fitted. Coefficients and predictions. Challenges and fixes. Challenge 1: The RANSAC algorithm can be sensitive to the choice of the residual threshold parameter. If the threshold is too high, the algorithm may include outliers in the inlier set, leading to a poor fit. If the threshold is too low, the algorithm may exclude valid data points, leading to an incomplete fit. Sample use case that resulted in challenge 1: A dataset containing a large number of outliers with a high residual threshold. Fixes to challenge 1: Use cross-validation to determine the optimal value for the residual threshold. Use a more robust method for fitting the linear model, such as the Thales-Sane estimator. Challenge 2: The RANSAC algorithm can be computationally expensive, especially for large datasets. Sample use case that resulted in challenge 2: A dataset with millions of data points. Fixes to challenge 2: Reduce the number of iterations by using a smaller value for the max trials parameter. Use a more efficient algorithm for fitting the linear model, such as the least squares estimator. Use a parallel processing framework to speed up the computation.